Okay, so let's talk about the idea of a linear operator being a matrix. And so, again, let's just breeze through the formal language here. So suppose we have a linear operator A from V to W, so vector space V, vector space W. So it's going to take some vector from V into W, linear operator. And in this case, we're just going to specify that the basis vectors for V, the components, we're going to call them V1, V2, V3, V4, and so on. And the idea here is just like I could say vector K, whatever, some vector is a combination of 3x plus 2y plus 8z, right? In this case, I'm just, instead of calling them x, y, z, I'm calling them v1, v2, v3. And the same is true for vector space W, right? I have a W1, W2. I have a different set of basis vectors here for W. In fact, and then what we're trying to say here is that for each number in a range, there exist these complex numbers that operate in this fashion. A being applied to a vector gives you a weighted sum of other vectors in the next vector space. And so this is one of those things that really helps to have an example. So let's say I have the vector V equals, let's say vector V equals 1, 0, right? So it's going to look like this, right? It's just going to be right there in the x direction, just 1 over, nothing in the y direction, only in the x direction, right? In fact, I can rewrite this as it equals 1 times v1 plus 0 times v2. So 1 times v1, 0 times v2. That's the way I'm choosing to write this. And so let me actually just get rid of this 0 because it's just cluttering up my board. I don't like it. And then when I use a linear operator A to take it from this space to that space, I'm going to translate the exact same vector over into this space. Okay, and now we see in this new space, and let's call this W1 and W2. Let's give them some labels. In this new space, we see that my vector has some component of W1 and some component of W2. And let's call it, 1, 2, 1, 2, 3, whatever. So let's say that in this new space, my vector, so I will say A being applied to V equals 1.5, so 1.5 times W1 plus 2.5 times W2. And in general, there is a set of numbers that I can arrange in a matrix so that it will look like the, I'll just make some numbers up. Let's say 2, 1, 3, 8, and act it on a vector 2, 2. That will give me some other values out of it, right? That will give me let's say 3, 5, whatever. And so all this notation really means is that our operator A can be turned into a set of numbers, a square set of numbers that will show exactly how we translate this. Let's dive into an example just to make this a little more concrete.